Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Ashirayu binti Muhammad Asnawi, 81901005. So, I will show you about the introduction of the theme and the task given, also the flowchart. So, here are the introduction of the theme. We already divide the task equally to each member, and the task given as shown below.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarul Arif bin Muhammad Zakaria. My matric number is AD170096 and I'm going to present about part design. For the first design, which is the milling, the material that we choose is mild steel. The thickness is 50 millimeter. Based on the table, the specification is for working speed is 0.6 meter per minute. And the shape of the finished workpiece would be a 60mm times 60mm square shape with a center depth of 5mm. And the depth of the shape is 40mm times 40mm, and the fillet radius is 10mm. For the next is lathe workpiece, which is the fabricated for the material is from stainless steel. Then the specification for this workpiece is for the working speed is 0.6 meter per minute, and the final result is a 70 millimeter length cylinder base shape, which comes with two different dimensions, which is on the front side of the radius of the cylinder is 10 millimeter. The chamfer is 45 degree and the length is 40 millimeter. Meanwhile, on the back side of the the radius of the cylinder is 50 millimeter. The chamfer is also 45 degree and the length is 30 millimeter. And for the next workpiece is drilling workpiece. The material for this drilling workpiece is pine wood. The base shape of the workpiece is 150mm times 50mm rectangular shape. The thickness of this workpiece is 10mm. The cutting speed as on the table is 0.6 meter per minute, and the final result is there are 4 total number of holes, which is located at the both side end of the workpiece. The hole depth is 10 millimeter and the hole diameter is 5 millimeter.
After that, we move forward to the flowchart for each machine to represent a workflow or process involved. So for lathe machine, the flowchart is shown on the slide. So for lathe machine, we have radius as an input. We need to enter the allowable length, width, thickness, and the useful energy. Then enter the parameter to be removed in order to get the result. If the thickness are low or equal to 30 mm, the machining time is C plus B divided by 100. If the thickness are less or equal to 50 mm, the machining time is A plus B divided by 45. And if the thickness less or equal than 70 mm, the machining time is A plus B divided by 45. All the formula involved for the thickness are same. For drilling machine, the flowchart are same as lathe machine, but the total volume and the machining time for each thickness are different. Also, it have pi as input. For the thickness less or equal to 30 mm, the machining time is A plus B divided by 100. For the thickness less or equal to 50 mm, the machining time is A plus B divided by 100. And if the thickness less or equal to 70 mm, the machining time is C plus B divided by 45. Also same for the milling machine, the process involved are same but different in total volume and the machining time for each thickness. So, for the thickness less or equal to 30, the machining time is A plus B divided by 100. For the thickness less or equal than 50 millimeter, the machining time C plus B divided by 100. And for the thickness low or equal to 70 millimeter, the machining time is C plus B divided by 45. After that, the result will be displayed and the program codes.
Assalamualaikum, my name is Muhammad Ashraf. So my metric number is 180107. So I will start with result code. Now the first one is a milling machine. So the result will be 1.2 minutes. So the total energy consumption will be 9 kilowatt. Material efficiency will be 100. Total operation cost will be 1022.5. So solid waste generation 0 kg. Estimated productivity per day will be 400 pieces. Next, for the LUT center, so part machining time will be 0.8. So total energy consumption will be 9 kilowatt. Material efficiency will be 100.01. Total operation cost will be 1522.5. So solid waste generation will be negative 1.1. So estimated productivity per day will be 600 pieces. Next, for the drilling center, our part drilling time is 2 minutes. So total energy consumption will be 9 kilowatt. So material efficiency will be 198.95. So total operation cost will be negative 74214.6 kg. So estimated productivity per day will be 320. So I think that's all from me. Thank you.
There are few formulas that are involved in the program. Below show the parameters and formula to run each and every code for the program. We have a lot of parameters, but we can only list down is volume, width, diameter of tool, material removal rate, waste generate, length, thickness, pi, and material efficiency. Next, the formula. Since it's already mentioned in operational analysis, here is the main formula that we use. Volume, material efficiency, output per day, machining time, waste generate, total operation cost, and power.
For conclusion, in this project, we have learned to design and run a program that relates for 3 types of machining. Next, we was also exposed to writing for formula to run the produce based on C++ code in the software. Lastly, we would be able to solve various types of problems related to DEV C++ software that requires the same method and technique. Thank you for listening our presentation.